Hello friends, today we are looking at calculating the slope of a line by using the slope formula. So our slope formula is m for slope equals y2, which is the y value of the second point, minus y1, which is the y value of the first point, over or divided by x2, which is the x value of the second point, minus x1, which is the x value of the first point. So to start off, we have the points -5, 7 and -2, 4. So I start with y2, that's my 4, because it's x first, then y, remember. And then minus y1, which is 7, over x2 of -2, minus x1 of -5. Now be careful here. Because there is a minus sign already in the formula, when we are plugging in a negative number after the minus sign, we have to be really careful that we include both the original minus and the negative. Now, technically, we can simplify this. So we could write it also as 4 minus 7 over -2 plus 5, because minus minus is the same as plus plus. Oops. Sorry. Either way we do it, the fact that we have a minus is going to change how it looks a little bit. But now we go ahead and we simplify. So 4 minus 7 is -3. -2 plus 5 is +3. So this simplifies to a slope of -1. So continuing on, our next set of points is -2, 2 and -4, 1. So again, we start off with our y2, the y value of our second point, which is -1. And then we have minus the y value of the first point, which in this case is 2, over x2, -4, minus x1, -2. Again, make sure you put the parentheses around a negative number that you are putting after the minus sign so that you don't accidentally forget about that needing to be a double negative. So -1 minus 2, they're both the same sign, so it's going to be a bigger negative number, so -3, over -4 minus -2, or plus 2. -4 plus 2 is -2. Now, number-wise, this cannot simplify. 3 over 2 is as simplified as it's going to get. However, because it's a minus or a negative over a negative, that can simplify out to a fully positive slope of 3 over 2. Our next set of points are 7, -5 and 16, 7. So we'll start with y2, which is 7, minus y1, which is -5, over x2, which is 16, minus x1, which is 7. Now, if this template is helpful to you, I do have a number of copies of it in my classroom, so you can use them when you need to. So we go ahead and we simplify this. 7 minus -5, or 7 plus 5, is 12, over 16 minus 7 is 9. Now this can simplify numerically by dividing both the top and the bottom by 3. So 12 divided by 3 is 4, and 9 divided by 3 is 3. And that's going to be our answer here. That's as fully simplified as it can be. Now, as you've seen with this one and the previous one, you're going to get fractional slopes a lot. Sometimes you will get whole number slopes, and sometimes you will get slightly more unconventional slopes, which we'll get to in a second here. For this one, we have the points -2, 4 and 10, 4. So we'll start with our y's, 4 and 4 again, over our x's, 10 and -2. So simplifying, 4 minus 4 is, of course, 0, over 10 minus -2 for 12. Now, when we see this, we want to stop, because 0, we know in a fraction 0 makes things weird. But be careful. When 0 is in the top like it is here, it's actually just going to simplify down to 0. Nothing crazy here. It's when we have it in the other position, in the bottom, where things get a little silly, as you see in a moment. So when 0 is in the top, it does not matter what's in the bottom. It could be anything else, as long as it's not 0, and it will turn out to be 0. So for our last one here, I have literally just taken the one before it and swapped the x and y values. So we'll end up with the same numbers, just what was on top is now on the bottom and vice versa. So the math still works out the same. 10 minus minus 2 is 12, and 4 minus 4 is 0. So when 0 was in the top, it simplified down to 0. However, if we try to put 12 divided by 0 in the calculator, we will get an error. Because we can't divide by 0. Mathematically, we don't really know what that could mean. So when we end up with a 0 in the bottom of our slope is called undefined. We cannot define it, we don't really understand it, so we leave it at that.